Hello, beautiful people. We are going to talk about arithmetic sequences. I've got 3 different examples, and we're going to go through the recursive and the explicit formula. But first, we need to talk about the recursive and the explicit formula. So, the recursive formula only helps us if we need to find the next term. All right, and that formula looks like this. A sub n is equal to a sub n minus 1 plus our difference. Whereas the explicit formula helps us to find any term. That one looks like this. A sub n is equal to my first term, a sub n, or excuse me, a sub 1, plus my difference times n minus 1. All right, so those are the 2 different types of formulas that we're going to talk about. We're going to find both recursive and explicit formula for each of our examples. So here's our first example. Example number 1. Negative 23, negative 17, negative 11, negative 5, and we could keep going. So the very first thing that I would do here, you guys, is I would find the difference, that common difference. And I'm going to do that in red, if I can find it. So I want to find the common difference, D. Here, I've got to think about if I'm increasing or if I'm decreasing. And here, I go from a small negative to a larger negative. So here, I am increasing. I am increasing, and I got to think about how much I'm increasing by. So I would take 23 minus 17. Oops, 23 minus 17. Delete that, Miss Ingram. Is 6. So I'm increasing by 6. Here, I'm still increasing by 6. And here, I'm increasing by 6. Meaning that my common difference is going to be 6. Now, we can write our recursive rule here to find the next term. My recursive rule is just going to be like this. A sub n doesn't change. A sub n minus 1, my previous term, doesn't change. The only thing that changes is my difference, plus 6. So if I wanted to, and I wanted to find this is my first term, second term, third term, fourth term. If I wanted to find the 6th term, I would have to find the 5th term and the 6th term, 5, 6. Meaning I would add 6 to negative 5 to get my 5th term. So negative 5 plus 6 is positive 1. Add 5 to get my 6th term. My 6th term is going to be 6. 1 plus 5 is 6. All right, that's it for the recursive rule. Recursive, you have to have the previous term in order to find the next term. Now, explicit is a little different. Explicit, you have to do some simplifying. A sub n is equal to my first term, negative 23, plus my difference times n minus 1. So here, I'm going to use distributive property. And I'm dropping pins everywhere. So 6 times n is 6n. 6 times negative 1 is negative 6. And I drop everything down. The only 2 things I can combine here is negative 23 and negative 6. A sub n is going to equal 6n. Negative 23 minus 6 is negative 29. Now, I can use this formula to find any term. So just for funsies, in a different color, let's use dark blue, we're going to find the 100th term. Meaning I'm going to take 100 and I'm going to plug it in for n. A sub 100 6 times 100 minus 29. Well, that's just going to be 600 minus 29. And you can take your calculator and you can calculate this because I don't know this off of my head. 600 minus 29 is 571. So 571 is my 100th term here. So we found the recursive formula, and we used the recursive formula to find the 5th and the 6th term. Then we simplified our explicit formula to find the 100th term, and our 100th term was 571. All right, and we're going to do the exact same thing, just with a different formula, or excuse me, a different sequence. So our second sequence is going to be this, number 2. We're going to do this one. 14, 23, 32, 41. And our process is still the same. We're still, and the sequence keeps going. We're still going to find the difference here, our common difference. Now, I got to think about this. If I go from 14 to 23, I am increasing. I'm increasing in my values. But what am I increasing by? I'm increasing by 9. From 23 to 32, I've also got to check, am I increasing or am I decreasing? And I'm increasing here. And then I got to think about, am I increasing by what? And so I'm increasing by 9. Also here, I got to check 32 to 41. I'm also increasing by 9. Now, I check to see if all of these, if my difference is the same number, because if it isn't the same number, then I'm not going to have an arithmetic sequence. I would just have a list of numbers. But it is an arithmetic sequence, so that means that my difference is 9. So taking this, let's find the recursive rule. A sub n minus 1. The only thing that I'm changing is my difference, my 9. So I can use this to find the next 4 terms. So if I'm thinking about this, this is my first term, second term, third term, fourth term, 5th, 6th, 7th, 8th. I can find the next 4 terms here. So to go from 41 to my next term, I add 9. So my next term is going to be 50. 50 plus 9 is 59. 59 plus 9 is going to be what? 68. Let me double check myself. Always double check yourself using the calculator. And then 68 plus 9 is 77. So my 8th term is 77 here. Last thing that I'm going to do is I'm going to write out the explicit formula. A sub n. My first term is 14 plus my difference, 9 times n minus 1. Now here, I'm just using distributive property. 9 times n. 9 times negative 1, just to simplify. A sub n is equal to 14. 9 times n is just 9n. 9 times negative 1 is negative 9. The only 2 things here that I can combine are 14 and negative 9. A sub n is going to equal 9n. That's a 9 there, 9n. 14 minus 9, always go behind yourself and use your calculator. 14 minus 9 is 5, plus 5. So here, instead of finding the 100th term, let's find the 23rd term. Meaning I take A sub 23, and I'm plugging 23 in for n. 9 times 23 plus 5. Now, I don't expect you to do this in the calculator, or to do it in your head. I expect you to use a calculator. 9 times 23 is going to be 207. 207 plus 5 is 212. So 212 is my 100th term here. 212 is my 100th term.